Hi everyone, I'm Rashmi and I'm a fellow copper. First of all, thank you for joining me for this session. And today I'm going to present talk on the topic titled as Software Still Eating the World. So in the first half of my talk, I'll basically cover the theoretical aspects of the event-driven microservices and why do we need that. And the next half, I'll explain through an example. And also, we'll see some of the frameworks of microservices which are available in code. So let's get started. So I really like this illustration which just talks about like how the software is eating up the world. And like we know that every organization needs a digital strategy in order to survive. And the customers of all these organizations, they are hungry for the best user experience. So gathering data, analyzing that data, and then making the relevant offers in the real time are the keys. Or maybe like these are certain parameters on which they want to optimize so that they could have a good customer experience. While the business stakeholders, they understand that within the organization, all the data which is at hand, but unfortunately, that data is either stuck in some legacy structure, which can be hard and complex. But yeah, generally, like it's kind of risky to touch also at times. So I'll explain through an example or through a story that how we can proceed with the need of the microservices, and then it's so as Halloween is coming up, and I'm so excited. I'm sure you all must be. So you must have seen like there are some special offers on the online stores, and also we know that in the online stores there are various functionalities. You have the product catalog, whatever the product that you're going to buy, shopping cart, and there is orders and the product search. So, like the traditional or the legacy architecture, I would say, they build these features um, into a single application or a single database. So kind of, like adding new features. So it just introduces like tightly coupled dependencies, and the application becomes, like hard to manage, or it becomes, like just a single package kind of an application. So in a microservice architecture, you have each component, and that's built in isolation, and it's kind of independent of all the other features. So like you can see that my orders functionality, it has its own database, shopping cart, product search. It could be having the same database, they could be interacting, but in general, like they are built in kind of an isolation. And the HTTP REST or message bus is used to allow these services to communicate with each other. But operating with multiple distributed systems and microservices also brings some unique set of security requirements. That's, like instead of single point of entry, they offer dozens or even hundreds of potential points of vulnerability. So, so one needs to be, like effectively secure in order for an application to operate effectively, and also one needs to take care of the latency issues which could come, like which does come when you are just interacting with one microservice to another. So it's kind of a, like a good idea if one builds some kind of asynchronicity to make it much more manageable, I would say. So yeah. And historically, most of the business applications, they tend to be data centric. They used to put like everything in the databases. And the priority was that you should always have kind of a valid copy of your data so that in case just anything breaks down or something, And also this kind of, this introduces a kind of the lockdown, and it's transactional in nature. Um, so in nutshell, your business was in your database. And that's very static way of looking at things. And it wasn't that much effective in terms of when you want to build like kind of responsive applications. So the other way of looking is at the things is kind of an event driven, where your data is flying around between the different pieces of the software. But I mean, because our priority definitely has changed. I mean, the priority is to keep the system much more responsive. So that's how it's being introduced. And for example, okay, let's consider an example. You have a banking application and you call an API saying, like, submit this payment. And then it just takes a bit of time to actually complete it, but it's not synchronous call. I mean, it's not a synchronous call. It definitely takes time. And then you will get, of course, a notification towards the end when it's completed or when the transaction has actually happened. So, yeah. So event-driven microservices, it's kind of a combination of the APIs and, of course, event-driven concepts at the same time. Like we have service discovery, we have the event backbone, and also some A/B testing tools. And yeah. So event backbone is kind of a messaging infrastructure that you have in the middle of your application. And it's kind of provides you it just wires your microservices together. And typically you use a publish subscribe model for messaging, which I'll describe in the next slides. But just wanted to give a the big picture is, it's loosely coupled way of doing a communication. So that's what publish subscribe is. Like in some situations, you will have the APIs between your microservices. While in some situations, microservices might publish an event and other microservices are subscribed to that specific event. So, I mean, the major takeaway is if in your application you atomize everything into the tiny little pieces of messaging, then it would be rather difficult to maintain. Yeah. So, yeah, these are the two different methods of messaging patterns. Point to point is one such, and the publish subscribe is the other one. So messaging is, it's kind of, like basically you're communicating between the two programs by sending the messages. And so here the producer sends a message and the consumer consumes it. That's how the holistic picture of it looks like. So in a point to point, you have a queue, and as an intermediate structure. So yeah. So the producer sends a message on the queue, and you end up with an ordered list. And the consumer then, picks the messages off, but each message is consumed by a single consumer. Yeah. And it's kind of a good way of sharing messages, but not really like an effective way. So, like when you want to just spread out the information, then it's not good in that case. So the alternative way is like publish subscribe. Like instead of having a queue, you have the topic. And in this case, you have the multiple subscriptions. So of the same topic. So it's good in a sense that you are finding out the information, which is what you need, right? So yeah. And a very common publish subscribe method of, or maybe like model of the messaging is Apache Kafka. You have sequencing events. It uses, for example, for sequencing events, it uses a stream processing, which is an optimized way of doing it. So it also has a very strong storage infrastructure as well. And most of the messaging systems have not particularly good amount of, or maybe like a good support of the enormous amount of the data which is flowing within them. So you need infra in order to take care of it. And especially when the data is quite old or static, then you definitely need a mechanism which can take care of all of it. So here you can see that we again have the producer and consumer. Yeah, these are like common messaging message processing terms, I would say. So a few of the things that you can do with Apache Kafka is as well the idea of the connectors. if you want to get events into your system from an existing system, then you can plug into the Kafka and you can generate the events. So yeah, that's how it's a holistic architecture. The next one is various frameworks in the Go. So there are a bunch of other frameworks as well, but these are like, like very popular frameworks in Go. So that's why I've just included in this. And also I'll go with these, I'll go one by one of these frameworks. So the first one is the Go Micro Framework. It's a, the micro is built as kind of microservices architecture, and it's just abstracts away all the complexity of the underlying infrastructure. And in the diagram, as you can see it here, how it works behind the hood. And of course, you can read more about it on this link. And it also has very comprehensible and easy, examples. I think I have it opened on my, Yes, over here, the introduction on high level, how you can start with using, and there are some features, so it's how they have defined it. Yeah, so there is also like getting started, how you can install and build your own service. It's just also they have one hello world example, so it's yeah, like you just need to go get and then this, and of course you can build to the binaries. And you can see how, hello world example is given here. So yeah, it's very nice, and it's also very comprehensible. It's easy to understand, very illustrative way of explaining about how it works. Yeah, so you should definitely check this out. The next one is okay. This that's a GoKit framework. You can read more about the link which is given here. So basically, the GoKit is again a collection of the Go packages that let you build more robust, reliable, maintainable microservices. And also, it has, it provides like kind of a lot of libraries for implementing the components for system observability and resiliency patterns, such as the logging metrics, tracing, rate limiting. These are circuit breaking. So these are like very important or essential elements for building the microservices in production. So it's quite nice. Yeah. On the Gizmo framework, as mentioned in the slide, it's an open source Golang, like based microservices toolkit which provides standardized computation and logging. And again, it has health check and the metric endpoints. Health check and metric endpoints are of course important when you want to see whether your API is working or that particular endpoint is working or not. It's just some logging, like one of these metrics. Yeah, and this toolkit was developed by some small group developers from New York. Nice. And one such interesting fact which I feel about the about the Gizmo that I think is that it has five service middlewares. So that wraps around the HTTP dot handlers, and its endpoints are HTTP dot handler funds. And that gives the developer much more flexibility to write the code that looks like a standard library that's make HTTP library in the code. So, of course, you can take the advantage of this automatically by collecting all these records for the status code. But yeah, it's quite familiar with all the existing libraries, so it's easy to surf on. And of course, you can read more about this on the Gizmo on this link. The next one is the type. It's again, it's a microservice RPC library in Go. It aims in a balance between easy and simple usage and performance, and can connect to other types. really like the terminologies in which I've described this for this particular framework. So and also again, it's easy, but just like sometimes you need to just see about the pros and cons in terms of economically or what your requirements are towards the end of the day. So yeah, um, there's also like beautiful blog about this type framework on the Kafka company, which I've linked it here. So you should definitely check this out. And also like the kite framework has this kind of control, which is a service discovery mechanism. It kind of controls and keeps track of the kites, and so that they can like securely talk with each other. So yeah, I think for this I would again go back and check for yeah. This is the article which I was saying, Coffee Economic article. They are like they have well documented it in a way how it is used, and they have also given an example. So yeah, so you can definitely check out this one. Okay, so next one is the last framework. I promise this is the last framework that I'm going to talk about. Um, that's a gym. Oops, it's low. Yeah, it's again very flexible and beginner friendly. It's high performance distributed framework and allows to build your web applications and microservices in it. And again, it provides similar support, which is great, and without even other mechanisms. Um, Again, you can read up on the GitHub link of the gym, and also they have various examples. And it's, as I said, yeah, it's a beginner friendly. Mm-hmm. So, time for a quick demo. I'll show you an example which I made using the Gen framework again. And it's MongoDB and Gen, both of them as it's a basic CRUD application. Yeah. So as like Halloween is coming up, so I was just thinking, like why not to make a product which is, like so all these endpoints like get posted, all these endpoints, and about fetching some of the data from the or maybe like just getting the data from the online store. So yeah, let's see the example. Okay, the structure again. I want to talk about first of all how I have three major layers of this application is of course the use case, the data service, and the domain model. I'll definitely upload this code on my GitHub and along with the slides for the reference afterwards. But before that, just wanted to like give you the high level of how I have structured it. Um, so yeah, so as I was saying, the Halloween is coming up. So why not the products? So to order the products online from an online store. Um, yeah, this is again the database connection, and you're getting the data by ID on the backend, and inserting and then you're deleting. It's a Mongo client, and also the Go has this Mongo client, so you don't have to do all the installation by yourself. Just a couple of resources that you need. And yeah, so first I'll go on the get endpoints. Firstly, are checking. Okay, I'll also talk about first this. The product has the ID, brand ID, and the rate, which is that's a structure you have defined of your product. And yeah, in the get Halloween product by ID, you are like by ID you can you're just sending the request and creating a function, and what will return when it's 200 hours status. Okay. For post, your when the again you are catching the error over here. So I think that's a very effective way, especially in the Go, when you can like catch the errors and you can actually document. So mostly that's how in the C you can do it on compile time. Yeah, so it's just great to have these features. So insert in the DPN on the basis of whatever the product and like, data that you want to read, and on the delete is by a specific ID. Okay, this is the product that you don't want, so you just delete it. That's a very simple example. That's how the presentation and the request models look like. Client, yeah, it's I told you about the client, so it's just easier to get that. And in the main.go, yeah, okay, and also in the routes.go. So here you just need to write, like the engine.get and the specific URL, and of course a function which you wanted to, whether it's a delete or the post. So it's yeah, and once and in the main.go, you just run on that particular code you need to define, or it's either I mean, you don't necessarily need to mention the port number, and of course your Mongo address. And here, when the client is being connected, otherwise if there is an error, then of course you have like the error while connecting. So yeah, it's a great way of doing it. And yeah, next, okay, and also how you can, okay, I've already done it, like go build, then main.go, then go run main.go. And on the postman, you can check about like using the get post or whatever the endpoint was, and then you can send it. I mean, through the postman, you can check about this. So yeah, next one is, so that was our demo. And the last one which I wanted to cover, why go for microservices? It's kind of, like you're using the Golang, and then why you want to do, microservices, not the monolith architecture. So on a side note, Go belongs to the, like the C family. Yet yet it's much more effective, I would say, as compared to C and C++. And of course, the syntax is super simple. Somewhat like the Python itself, I would say. So it just lies between the near some Python, some C++ family. So it's just not like entirely like that kind of a language. So yeah, it's and as we know, the Go it's the king of the concurrencies being considered. Especially the Go routines, if you are aware about it. And the static type of language it also has a great readability. Have you heard about what's that say as clear is better than clever? Like one of the proverb which I'm just telling you is, so that's why it just has much better readability. And code formatting, again, it's opinionated. So about the code formatting, and also has a tool OFMT which automatically formats your code, so you don't have to worry about the linters and the video and all these kind of tools. So, and then yeah, on the highlight, I would say is Golang's performance. I mean, the Go performance beats the Python and Java's performance by a real high number. So you should definitely check this out. And yeah, I think king of the concurrency is what I say. I'm a static type, and so which means the compiler can do much more work for you. So it's static type, so that's and yeah, and you should definitely check the proofs, even if you don't want to work in code. But I would definitely, I think somehow it's a great language. So yeah, so that's all I have for the talk. Hope that was a bit helpful. Or I'm open for any feedback. And I really thank for joining in. I really thank you all for joining in for the session. Bye.